welcome all to the workshop. So I've been really excited to present this workshop. So just for a little bit of context here, before I actually started this project, my technical experience with LoRaWAN networks and LoRa was a little bit lackluster. I knew about the technology, but I actually never really got involved in using it. So it's been really awesome to do this project. And so I wanted to level straight out the back with you. I'm combining my Influx experience here with my now new LoRa experience to present a project to you from start to finish. So just a little bit about myself first. Let me see if I can jump on. So I'm Clifford. I'm a developer here at InfluxData. In my past life, I was a sales engineer for industrial IoT solutions. I have a strong passion in like the autonomous and vision-based projects. I'm driven to make IoT accessible to all. And my belief is industrial IoT success belongs with the domain experts. So we are going to go from start to finish, from setting up your development environment, provisioning your device, all the way through to putting a front-end application on your Influx DB instance. It's going to be quite a lot, but we will try our best to get through it. So part one will be environmental setups. We'll be looking at setting up VS Code, the device itself, the Thing network. Part two will be connecting the Thing network to, the Things network to Influx DB. So that'll be using Telegraph and setting up Influx DB. Part three will be a custom IoT application. So I'll be showing you how to create your own custom IoT application and query and visualize data from Influx DB. Part four will be showing data transformation capabilities in Influx DB. And last of all, showing how to do automated alerting in Influx DB and potentially tying that back to your custom application. So let me quickly jump on. But before I get to that, what I want to do was give you a bit of a background of what we're trying to do here. So my project in this was to develop an application that was going to monitor the health of my plant. So this was originally conceived by one of our dev managers called Rick Spencer, and it's called Plant Buddy. And essentially what we're doing is we're monitoring, taking a bunch of sensors, we're streaming that data from our microcontroller, and then we're putting that onto a LoRaWAN based network. Now, what I want to do is quickly define, in my opinion, what the LoRaWAN network is, and sort of give you that overview. So you've got to split it into two. So first of all, you've got what we consider is LoRa. So LoRa is the wireless modulation technique, and you can imagine this as, it almost is a bit like dolphins or bats. It's a bit like the sonar signal. It's a long-range wireless protocol, which runs over radio. And essentially what this does is it allows you to send and transmit data over long distances, vastly further than like a standard wireless network. And so we can actually do this on devices at extremely low power as well. So what a lot of LoRa devices are capable of is running off external small batteries. So you can have these in quite remote locations. The cool thing as well is the actual bandwidth for the frequency that these LoRa devices run with are on basically protected networks. So only LoRa-based frequencies can run on these networks, which means interference from other signals isn't quite regularly a problem. So the next layer up is what we call a LoRaWAN. So you can imagine this like the MAC layer protocol, basically like a standard wireless network, but the under backbone is LoRa. And this is what a standard sort of LoRaWAN network would look like. Stolen with pride from the Thing network team, just to show you exactly what this looks like. So what this comprises of is a series of nodes. So our nodes here could be considered our microcontrollers that have LoRaWAN connectivity functionality. We then have our, sorry, I'm just making sure I got the right notes on this going through. We then have our network server, which is here. But before we have our network server, we have our relays, and these basically bounce the information coming from our nodes directly to the network server. So you either have them as relays or gateways. They basically just route the information directly to our network server. And the network server itself takes all the information coming from our end devices and translates that data coming from the LoRa node. So basically takes it from serial form, takes it from an encoded form and transforms that into what you need it to be and manages all of those devices all around the network. And then what network servers usually have as well is an application server. So the application server is a selection of services which allows you to do really cool features such as offload your data to other raw protocols. Maybe that be HTTP, MQTT, to other cloud services, and also potentially allows you to manage devices as well, which we'll see in a moment. So what I want to say to you straight here is we keep throwing around the Thing network and the Thing stack. So the Thing network is essentially a community-driven, open source LoRaWAN network that anyone can connect to for free and stream their data. And what the LoRaWAN collective do, what the Things Network collective do, is they actually run this open source community edition called the Things stack. And now the Things stack runs on their network server, and that basically allows you to manage, maintain your devices and stream data from those devices to the network server to allow you to stream that to your other applications. And from there, of course, that's where we come in as InfluxData. We'll be taking the information from the application server and the network server, streaming that to InfluxDB Cloud or InfluxDB Edge using Telegraph. So without further ado, let's get cracking. Let's work through. So first, we're going to talk about the environment setup. So here is our LoRaWAN microcontroller and sensors. So all I'm using here is an Arduino MKR 1310. So this is a really cheap device. You can get it for about $30 to $40. And essentially all you can do is you can basically put it on a breadboard and wire up a bunch of lightweight sensors. It comes with an integrated LoRa chip, which allows you to connect directly to the Things network and basically to a LoRa network of your choice if it's not the Things network. And all I've done is I've combined it with a sensor pack, a really cheap sensor pack. So in this case, we have the temperature and humidity, a light sensor, which is based on a photoresistor, a soil and moisture sensor, and a soil and temperature sensor. So I've got the GitHub repo for this, which also contains all of the code for the microcontroller as well. So you can actually just use that code directly if you're buying one of these, and you can basically use that to do the demo yourself. But let me show you what this looks like in terms of code. So if I jump into our Arduino code here, all you can see here is essentially I am wiring up a bunch of, hello.
Is it possible to zoom in a little bit?
Oh yeah, let me see if I can zoom in for you. What's too small?
Just the text.
Is
it possible to, usually you can zoom in on terminal windows.
Yeah, there we go. Is that any, oh, I've gone a little bit far now.
That looks good. That looks better. I hope everyone it looks good. Yep.
Awesome. But yeah, so essentially within this Arduino code, all I'm doing is I'm pulling the readings of the sensor data, and then I'm connecting directly to the Thing network. So that's all within this code base, which you can see here, but we can cover that in depth if you want to at another time. So moving on, let's discuss setting up your VS Code environment for dealing with Flux. So if you didn't already know, is we actually now as InfluxData have a Flux plugin for VS Code. And this is an awesome tool which allows you to add Flux language support directly to VS Code, and also provides administration features for your Influx plugin. So it means you don't actually have to jump into Influx anymore in order to work with your InfluxDB instance, which is awesome, because a lot of the time I found it so disjointed to jump from VS Code and then jump out of VS Code to do stuff within Flux and then jump back into VS Code. So let's have a quick look at installing that. So all you need to do is jump into extensions. You need to search Flux within Flux here, and then you would click install. So I already have the instance installed here. From there, if you jump back to your Explorer, and if I jump here, and then if I jump into our section, we see, as you can see in our Explorer, we have a new panel called Influx DB. From this Influx DB panel, all I would do is click plus, and this allows you to define a new connection. So you can define an arbitrary name, then you would add your host, Your token, I recommend using an all access token since it allows you to use all the administration features, and then the organization name that you wish to connect to. And then you can test and save. So if I quickly show you this, if I edit my connection, you can see I'm connecting to my cloud instance here, my token, which I won't show you, and then my organization name that I'd be connecting to. And once you're connected, you'll be able to see something that looks like this. So you'll be able to see your buckets, your scripts, and your tasks, which allows you to navigate through these all directly from within your VS Code plugin itself. So we're going to park this for now. We're going to get to this later when we discuss the custom application, but I just wanted to set up VS Code plugin from the start. So the next thing I wanted to discuss was connecting our Arduino device to the Things network, or so Things network or the Things stack. So let's jump over to that now. Hey, Caitlin, is that okay? Is this a good size? Or do you want me to zoom in on here too?
That looks good.
That's okay, awesome. So essentially, this is the control panel for the Things Stack Community Edition, which is the Thing network. We could do an entire webinar just on this, so we won't. But what I want to do is get you guys up and started quickly. So what you're going to do is you're going to jump into Go to Applications. From here, you would create a new application. I've already created an application here. It's really simple, just define an ID, a name, and a description. Not much to do there. Once you jump into your application, you come to your application control panel. And this is where it gets interesting, where you can actually start adding your devices, formatting your data, and then you can also look at integrations to other platforms, which we'll be doing. So what I wanted to show you is I already have 2 devices set up, one here in Edinburgh and then another in Newcastle. But to define a new device, what you do is you click Add End Device. Luckily, what the Things Stack have done is they have a library of devices, but you can define them manually as well. But essentially, since I'm using an Arduino device, which is quite a standard device, it's within the library. So I click Arduino, the model, the hardware version, and the software version. Top tip here, this got me. There is a new version released from Arduino. I think it's 1.3.0. And this is not currently a firmware version on the Things Stack yet, but don't panic about it. It works just fine enough, leaving. So you can go up to 1.3.0 as your firmware version on your microcontroller, and it will still work for the Things Stack. So don't worry about that. And then you would be defining your region. So your region is defined based upon where you are in the world. So there's currently 3 regions. There's the US, Europe, and Australia. And I believe there's other, I think that's defining other subset regions, but that's not in my area expertise to give you advice on that. So once you do that, you can finish the registration of your device. So you'd be selecting the frequency plan. I always go with the recommended SF9. You can create an app ID. So you generate your own app ID here. You could fill it with zeros, but that's not exactly good practice. So just generate your own app UI here. This will also go within your Arduino code as well, which I've outlined within the code that you must fill in. You can generate a dev UI, you can't generate a dev UI, that's a lie. The dev UI comes from the manufacturer itself. So when you turn your Arduino on and you look at the console, it will give you your dev UI, which is basically normally your LoRa chip that's on there. They have like a little serial code on them. So that's what that normally is. And then you would generate your app key. So the app key is just that security code for allowing you to connect to your LoRa instance. Once you've done that, you click register and your device should connect. So if I jump over to here, and if I click on my Edinburgh device, you can see here that I have my live data coming through. I'm located with my Edinburgh one here. And I have all of this good stuff filled out. So my dev UI, my app UI, and then I obviously have my security app key as well, to make sure that I'm securing my connection to my device. So if I have a quick look at the live data here and I jump in, you're going to see something quite interesting. So the live data coming from these devices actually comes as a byte stream. And this is because within LoRa networks, payload is king. Like the smaller the payload, the better. Essentially, this is due to your timing error and your transmission. So the longer airtime that you have, the worse it's going to be. This is a chance for your actual data to become corrupted, certain bytes not getting there, etc., etc. So what you want to do is you want to be able to condense your payload message into a small bite-sized message that you could then format on basically the server side of the Thing network. So this is what we're going to do. So I've, within the Arduino code, taken all my sensor data, turned it into like a byte array, and I've sent that along my LoRa network. I've received it here on the Thing stack. I'm now going to convert that byte stream back into a JSON payload. So if I jump over to payload formatters here, all I've simply done here is used a bit of simple JavaScript. So I pulled in my bytes that I've received from my device. I then convert that from the char code, and then I place that within a JSON payload. So you can see that JSON payload here. And then all I've done is basically pass that soil moisture, air temperature, humidity, soil temperature, light. And what you'll be able to see from the live data is you now should be able to see that payload converted here. So you can see all my values from my sensor here. So this is how far we're going to go in terms of connecting up our device here before we start streaming our platforms. So for me, there's a lot more that you can do within the Thing network itself. This is me at a beginner's level, showing you a beginner's level overview. So this is me connecting my device and streaming data directly to the Thing stack. So from there, we're going to move on to connecting our platforms. So this is where we're going to connect the Thing stack community to Influx DB. And what we're going to do first is we're actually going to set up Influx DB to make sure that's initialized and ready to accept the data that we want to send to it. So I've actually done a lot of the hard work for you. I've created two Influx DB templates called Plant Buddy and the Things Network. So if you don't know, an Influx DB template is basically a YAML configuration file, which automates the setup of dashboards, buckets, tasks, variables, lots of the assets that you require to run Influx without you needing to define them manually yourself. So we have an amazing community library of these for lots of different applications, not just these two. So yeah, definitely check them out if you are using a different platform as well. But yeah, so let's go and install these two templates now. So if I quickly jump over here. So this is our repository. I will send you a link at the end, and we have our two templates for Influx here, which you can see here. We have Influx DB Plant Buddy and the Thing Network. So to install these two templates, you can go into buckets. So you can go into your Influx instance. You can go down to your configuration down here, and you can click templates. Jump into templates, and you can see I've already copy and pasted one here. What you need is the raw file. So to get the raw file, all you simply do is if you jumped into the YAML file on the Git repository, click raw, and that gives you your raw URL. And you would copy and paste that directly into this URL here. And then you would click lookup template. And when you click lookup template, it shows you the number of assets that you have ready to go. So I'm not going to install this template directly because I've already generated the assets in my cloud instance. So they already exist. Since I already exported the template for you. But you can see there's a number of them here. So including buckets, tasks, Telegraph configuration, and dashboards. So I will give you a whistle-stop tour of those in a second once we've configured Telegraph. So let me quickly jump back over. So the next thing we need to do is configure Telegraph. So if you don't know, Telegraph is an open source metrics collector that we as InfluxData manage. It's completely open source, so everyone can contribute plugins to Telegraph. So we have over 250 to 300 plus plugins now. Some of those input and plugins include OPC-UA, MQTT, REST, Modbus, like AWS CloudWatch, Like there's loads of specific and also more general plugins. And then we also have output plugins to a variety of different sources as well, whether that be, directly to Influx, which we'll be doing now, maybe to MongoDB or a SQL database, other enterprise platforms. Telegraph really has a plugin that fits everyone's needs just about. So essentially what we're going to do is we're going to configure our Telegraph config. And the way I'm going to show you this is we're going to first generate an event, like an environment file, and then we're going to generate a things network broker password. So let's work through that together. So if I jump back into our configuration, and let me bring up, this is the only thing making this bigger. There we go. Awesome. So let's quickly work through our Telegraph config. So if you haven't seen a Telegraph config before, essentially Telegraph in most cases is no code and just works with this conf file to tell Telegraph what plugins to use and how to work with the data. So as you can see here, we have two output plugins, which are pointing to different buckets within my cloud instance. One pointing to Plant Buddy and another one pointing to Thing Network Stats. Then we also have two input plugins for the MQTT consumer, and this is how we'll be connecting to the Thing stack and streaming data to Influx DB. So you probably could do this within all one MQTT consumer, but just for the purpose of simplicity, I did it as two separate input plugins. So for this first one, all I'm doing is collecting the stats from the LoRa network itself, because I also want to monitor the Things network as well to make sure that my devices are connecting and are healthy connecting to that network. So essentially all I'm doing is I'm subscribing to the Things network server, which I'll show you where to find this URL. I'm subscribing to the top level topic within that MQTT broker. I'm defining the username and password for that broker, that Things network broker, and then I'm defining the format. So it's really important that the payload format is JSON. So we will be pulling that JSON payload. We will be converting that JSON payload into line protocol and sending that to Influx DB. But that's all done automatically through Telegraph. So as you can see here, I've also defined a tag for my devices. So that means I can filter based on my device ID, which is great. So I can keep my devices separate within my data. So I can basically drill down and understand how each device is performing with regards to the network. From there, I'm looking for the uplink message and the uplink message metadata. And then I'm excluding some keys that I don't want. And then lastly, I'm doing equivalently the same for the MQTT consumer for Plant Buddy. So you can see that here, basically the same type of stuff, but the only information that I want is that decoded payload, which we saw earlier. I don't care about any of the other meta information, just the payload to go within the Plant Buddy bucket. So you can see that here. So what I'm going to do now is I'm going to show you what I meant by an environment file. So the reason why I suggest using an environment file is for security. So what you could do is you could define your username and password directly within the conf itself, but that's just not secure. So the next best thing you could do is set up environment variables to define those. So all I've done here is I've set up an environment file with exports. So I've exported my host, my org, where my token should go for Influx, and my Thing username and Thing API key. And so all I would do is simply source this file before, so something like this. So source, find out where this, I've put this, it's a microcontroller, and then Thing network. And then if I jump into .env, I think it is, yeah. There's a pass here. Okay, that's just because of what I'm doing here. Sorry, that's my bad. I haven't filled these in. But essentially you would source this file and then you would run your Telegraph config. And then that would basically fill those environment variable spots in your Telegraph config. So let's find out where you need to pull these from. So if I quickly jump over to back to our Thing stack here, if I jump into integrations and go to MQTT, we can actually directly, the Thing stack actually has an MQTT broker directly installed on the server itself or within the Thing stack that you can utilize. So here's our public address that I want to know. You also have a TLS address if you want to use that instead to be more secure. And then you also have the username and password. So I would want the username out of there to go into my environment. And then the password, I can just generate a new API key. So if I generate a new API key, copy that, and then I would paste that directly into my Thing API key here. I'm not going to do that now, just because I would be exposing a password on a webinar. So once we've done that, all you need to do is to test that connection. Just simply run telegraph --debug --config and start up your configuration. So note just on this, you will only ever receive data from the Thing stack via Telegraph when your device is pinged home. So when your device is pinging data to the Thing stack, that's when you'll receive data from their broker. It's not on an interval. So that's how you would know, just to make sure. So say if your device is only sending data every minute, you would only receive a message every minute in Telegraph. So I've basically got a home server at home where I run my Telegraph configuration from. So that's all pre-set up. So I'm already streaming data directly to my Influx instance. So I can quickly show you that now. So let me jump back into Influx itself. If I go into our dashboards, I can show you our Things Network dashboard here. So this is the one I've created. And if I query this, you can see some of the information that I'm gleaning from the metadata from our Things stack. So the locations of where the gateways of where my devices are pinging to. So obviously there's one in Edinburgh and there's one in Newcastle. The bandwidth from which my devices are talking on, the consumed airtime, which we said is quite important. So clearly my Edinburgh device is a much better connection to my to the gateways than the device in Newcastle, and that makes sense because of where I place my device in Newcastle. I have meta information on my actual devices themselves, including meta information on my application that I'm hosting on the Thing stack. And then we also have some really interesting information on channel RSSI and channel SNR as well, which is fantastic. And then we also have correlations between those. And this allows you to really monitor granularly how well your devices are performing on those connections. And I'm going to have a shout out for one of our community members. So this bottom visualization that you see here comes from one of our community members using the Thing stack already. And he's a great guy in the UK called Mike. And he basically found a way of showing the connectivity cycles between your sensors. So it's amazing to see what the community has to offer here already, and how it gives back to Influx every day to show different ways you can monitor your networks. So the next thing I wanted to show you here, lastly, was Plant Buddy itself. So we have a Plant Buddy dashboard, which you can see here, which actually shows the data from our sensors. So you can see I'm monitoring on a per device basis. We defined that tag, if you remember rightly, which shows you the soil moisture, the histograms, the air temperatures, the air humidity, soil temperature, light, and then correlations between those both as well. So that's great. That's great as a visualization to make sure that we actually have data coming into Influx. But why don't we take it a step further and create our own custom front-facing application that we would give to users, rather than them jumping into Influx to use any of the UI there? So let me jump back over here. So for the custom IoT application, I decided to use Plotly, Flask, and Flux. So and the Influx DB client UI. So I decided to use Python because it's what I'm most comfortable in, and it allowed me to use a variety of different libraries to show you there's a lot possible using Influx as your backend. So within this, what I want to show you is how to create a Flux file, how to parameterize a Flux file, and then send that data and transform it into a data frame before we visualize it with Plotly. So if I jump back over to our VS Code here, let's start working through this together. So let me jump into our Flux files. So if you have a look here, this is a static Flux query, which you're probably all familiar with from the Data Explorer if you use the UI itself. So essentially, I'm querying from bucket plant buddy from the last hour, and I'm filtering under the measurement sensor data under that device UID, which is my Edinburgh device, and I want to know the data from the light sensor. So the cool thing that we have about that VS Code Flux plugin that we installed is we can actually run the query directly from VS Code, which is awesome. So let's have a look at this. So I actually can see now a table of that data which is returned. So you can basically query directly and see that raw data without actually having to jump directly into Influx DB. So I have the values here, the fields, and the times in which that they've come in over the last hour. So this is great, but this is a static query. So imagine if I wanted to pull data about our moisture sensor in, well, I would have to build out a Flux file for every single sensor, which is just not efficient. So I really wouldn't do it that way. So what I could do is use parameterization, and parameterization allows me to make my Flux files a lot more dynamic. And I basically just done this through simple formatting and injection in Python. So if we have a look at our graph Flux file here, you can see that I've just parameterized the parts that I want to make dynamic. So I want to parameterize the bucket, the device ID, and the field, which if I then jump into my actual Python code, if I jump into my Influx helper here, you can see that I'm actually calling here. So I've got a wrapper function called query data, and I'm expecting bucket, measurement, and field. And then essentially what I'm doing is calling that Flux file, and I'm injecting those bucket, field, and measurement variables into those parameters. And from them, I can then send that query directly to Influx and query for that information. And now this is a super awesome feature that we've added to our Influx client library for Python, is we can pull that data back and we can convert it directly into a pandas data frame. So, at Influx, we understand that there is already, data formats and data formats and tools out there that people are using every day that are industry standard. So, pandas data frame has been here for, from people from start to finish with Python, especially for data scientists, people working with large quantities of data and analytics. So we have an automated process of converting whatever influx data comes in and turning it directly into that data frame. So I query and I save the result, the resulting data frame from that query in result, and I return that. So where do I actually use this query data function? Well, if I jump into our application here, you can actually see I'm using Plotly Express to visualize my data. So from the code here, all you can see is I'm defining a Plotly Express instance, and I'm defining a line graph. And then I'm basically taking that data frame and taking the time, the value, and the field as a title and generating those visualizations. So let's see this in action. Let me quickly jump here and run. This is where demo woes happen and everything breaks on me, but I'm hoping to the demo gods it will not break. So I quickly jump over here. Fantastic. Okay. And to anyone who is a front-end expert or out there, or please do not shoot me for my horrific bootstrapping here. It was just to show you a demo. I am no whiz when it comes to front-end design. So what you can see presented to you here is Plant Buddy. So this is my front-end IoT monitoring application. And as you can see, you can jump between tabs and look at the different data that we've queried DB as our backend. So you can see soil moisture. I can jump between tabs and look at soil temperature and air temperature. And that's all done through parameterization. We're calling the same functions in that same Flux query over and over, just with dynamic parameterization there. And then I can click and generate new graphs, which is fantastic. So this is a really basic idea. Obviously, I expect your front-end IoT applications to be vastly superior and vastly more complex than this, but I just wanted to give you a brief idea of what a simple IoT front-end application would look like. So I think we're actually doing reasonably okay on time, are we, Caitlin? Have we got like 10 more minutes or so? 10?
Yeah, go for it.
Sweet. Okay, so I want to introduce you guys to some of the more interesting Influx DB features that sort of bring this project to the next level. So what we're going to introduce is data transformation. And data transformation can be done using a task within Influx. You can imagine a task like a cron job. And this basically allows us to perform a variety of manipulations on our data for whatever given reason. So within this scenario, we've basically said, look, we're collecting data every minute from our sensors, which is awesome. We now know how our plant's feeling every minute of the day. But do we really need to know how our plant's feeling every minute of the day? Some people would say yes. I would say I don't have enough time for that. So really all I care about is knowing that my plant is okay maybe every hour of the day. And maybe I only want to know how it's been doing in 10-minute intervals of that hour. So essentially what I've done is I've defined a downsampling task, which will allow me to, which will run every hour and take the last hour of that data and then iterate over 10-minute intervals and take the last value of those 10-minute intervals. If in this case, it would have been an average. So I can take an average over every 10 minutes. But for this use case, I'm just going to keep it simple and do the last value over those 10-minute iterations. So what I'm going to do is I'm going to quickly do this in front of you now. And the cool thing is we can do this within the VS Code plugin. So we actually don't have to jump into Influx again to be able to do this. So if I jump in, I've actually provided the task for you as part of the template. So if I quickly jump into our Plant Buddy downsampling task, I click edit task here, you should be able to see this task that I've generated for you. And so just to run through it again, this runs on every hour. I pull in the last data from the last successful task. So this is an awesome wee little feature. So instead of running based on an arbitrary pull, I can check when my last successful run of this task was and only pull the newest data from that last successful run. I then filter for the measurement sensor data. I then aggregate that data into 10-minute intervals and take only the last value of those 10-minute intervals. And I then basically push that data into a new bucket called downsampled. So this means I can set retention policies on my data, which is more efficient for storage. So maybe I might only set a 1-day retention policy on my raw data, and I can set a 30-day retention policy on my downsampled. So that would improve how much data I'm storing. So the cool thing here is I can actually run this again directly from VS Code. And you can now see the time is I'm only taking the 10-minute intervals like I expected to. So that last value and every 10-minute interval, which you can see here. Awesome stuff. So that's a downsampling task. That gives you an overview of what you can do from downsampling. What about if I wanted to add alerting to my IoT application? It'd be fun. So you can actually do alerting directly from the Influx DB UI, but I thought I would show you what an alert looks like as Flux. So when you generate an alert from the UI, what you're essentially doing is you're generating a glorified task. So the task is built with basically the alerting library and the check library built in, and allows you to send that data, send those alerts to where you want to go. So you can actually code the alert yourself, which adds a lot more customization and a lot more flexibility to how you want to prepare and how you want to send that data. So let's have a look at that now. Let me quickly check. Yeah. So let's have a look at the create notification. So if I jump into our task here again, I have our Plant Buddy moisture test here. So if I click edit task again, what you can see here is I've created a check and notification. So the separation here is a check is what's checking your data, see if it goes above like a certain threshold, or maybe it's like a dead man's check and you haven't got data coming in for a certain reason. And then you also have a notification. So where would you like your message to end up? Like where would you like to send the alert to? So if we look at the data here, essentially all I'm doing is I'm querying my sensor data for soil moisture under the device ID that I have here in Edinburgh, and I'm checking for a trigger. So if my soil moisture is smaller than 50%, then I want to know about it because my plant needs to be fed. The message FN here allows me to define a template for the message I would like to send to my endpoint. So I'm basically just saying my plant's getting thirsty, my moisture level is at this percentage. I then basically take all of these building blocks which make up our check and notification, and then I put them in and I build them together within this task data here. So schema fields as column, you can imagine like a pivot. We'll be moving to pivot at some point, but the schema fields and column is just something that's translated over from the early days of Influx V2, and it's just constantly used within a task. Monitor and the monitor libraries here allows us to create that check and that notification for our data. So I'm just using a simple Slack endpoint here, but I'll tell you what you can use later, which will be more interesting. So the cool thing again is you can actually run this query again, which is even more interesting because it gives you the end result, and you can see this is my checks and my moisture test, the level's okay. Here's my message. So this would be what my message would have been if there had been a problem. So your plant is getting thirsty, moisture level is at 66%. And you can see that the message should not have been sent. I will need to check why that got sent. But you can see it should have been when the threshold is hit. The threshold hadn't been hit, so the data would not have been sent. Essentially, how it should have worked. That's probably something in my code that I've done wrong there. That's on me. So actually, you should be able to see a Slack notification from me doing that. If I quickly jump into Slack, there we go. And if I jump into here, you can see my Slack notification here. So getting 30, moisture levels at 66%. So the cool thing that you could do instead is you could replace the Slack notification with a HTTP endpoint. And I've done some of the groundwork for you. So this is your homework to do it yourself, is you could actually expose your application onto the internet. Expose is probably a bad word, but then connect your Influx DB instance to that HTTP endpoint and send a notification from Influx to your user application to say to them, hey, here's a notification, your plant is thirsty, you need to water it. And you can find that in the main application here. I quickly jump back into app, and I cross off this, and I jump down. You can see our notify route here. So essentially all I would do is I would use our HTTP Flux endpoint, and I would post that message directly to this endpoint, which would create a notification within our IoT application to say, alert the user that our plant needs watering. And so you can see it's all really basic at the moment, but these are the building blocks to building a fully fledged IoT application from the ground up using, all open source applications and platforms. So apart from buying the sensors and the little microcontroller, this cost me no money. You can use Influx DB for cloud for free to a certain extent, and you can use the Thing network for free. So you can build a monitoring application for your house, for a proof of concept for an industrial customer that you might be using, all for free, all for using, community-driven projects, which is, why we love to partner with people such as the Thing network and the Thing stack that are working on these projects, just like we're open source with Influx DB itself. So last but not least, let me quickly jump across. Next steps. So why don't you have a go yourself? I always think it's better to do than to listen to me rabbit on all the time. So there, I've put all of the code on Influx community. You can download the repo there, and you can actually just get up and started with the code that's on there. It'd be great to see some of you get involved, maybe commit some of your own code, some of your own ideas. I would love to see it. It would be really nice. And I know Rick Spencer, who's worked on this originally, would love to see some contributions to this as well. It would be fantastic. It's a cool little project, and we're hoping to see lots of little plant buddies spark up all around the world. So yeah, I'm hoping you guys all get involved and then join us on the Plant Buddy revolution.